What is PLC? Programmable Logic Controllers, PLCs, are specialized computers used in industrial settings to control automated devices and processes. These advanced systems are equipped with both hardware and software elements that enable them to efficiently monitor inputs and manage outputs, enabling functions like turning devices on and off, based on predetermined logic programming. What are the parts of Programmable Logic Controller? The parts of a Programmable Logic Controller, PLC, typically include input modules. These modules receive signals from external devices such as sensors, switches, and other input devices. Output modules. These modules send control signals to actuators such as motors, valves, and relays to perform specific actions based on the input signals. Central Processing Unit, CPU. The CPU is the core component of the PLC, responsible for executing the control logic programmed into the PLC and coordinating communication between input and output modules. Memory. PLCs contain various types of memory, including program memory, where the control logic is stored, data memory, for storing variables and other data, and system memory, for storing operating system data and instructions. Power supply. The power supply provides the necessary electrical power to the PLC and its components. Communication ports. PLCs may have communication ports for connecting to other devices or networks, allowing for remote monitoring, control, and data exchange. Programming interface. PLCs are programmed using specialized software, and they often feature programming interfaces such as ports or connections for programming cables. Rack or chassis. In modular PLC systems, input, output, and other modules are typically installed in a rack or chassis, providing a physical structure for mounting and organizing the components. These are the basic parts of a PLC, although the specific features and components may vary depending on the manufacturer, model, and application requirements. What are the advantages of using PLCs for automation? Flexibility. PLCs are flexible and can be easily reprogrammed or configured. Reliability. PLCs are designed to operate in harsh industrial environments. Cost-effectiveness. PLCs are cost-effective compared to other automation solutions such as relay logic or microcontrollers. Speed. PLCs can process inputs and outputs at high speeds, making them suitable for time-critical applications where quick response times are essential. Scalability. PLCs can be easily expanded or upgraded to accommodate additional inputs, outputs, or functionality. Diagnostics. PLCs offer advanced diagnostics and troubleshooting capabilities, making it easy to identify and rectify issues. Integration. PLCs can easily integrate with other automation devices such as sensors, actuators, and human-machine interfaces. Safety. PLCs are equipped with safety features such as interlocks, emergency stops, and fault detection systems to ensure safe operation. Thanks for watching. Please subscribe, like, share, comment. IIQA